So in chapter 5, we're going to be dealing with rational functions. So that's functions that are fractions. So we're going to talk about two more parent functions. The first one is called the reciprocal function, and that's just going to be 1 over x. So we're going to just plug in a few numbers and see if we can figure out what the graph's going to look like. So I'm going to put -2 right here in the x. So I would have what, -1/2. If I put -1 underneath there, I'll have I'll have 1 over -1, just -1. Let me skip that 1/2. We'll come back to it. But this one, 1 over 0, we can't have that. So that's undefined. We'll talk about what that means in just a second. Let's go down here to the 1 and the 2. Put a 1 in there and I'll just get a 1. Put a 2 in there and I'll just get 1/2. Let's come back to these halves, okay? So if I put 1 and then I put this -1/2 under there, that's 1 divided by -1/2, or 1 times 2 over -1. That's going to wind up just being a -2 right there. So I'll have -2, and I could do the same thing with this 1/2. It would be a positive. So it will be a +2. So when you plug in a fraction, it actually turns into a whole number. So let's talk a little bit about what that undefined means. This undefined means that whenever x is 0, I am not going to have a number there. So that is actually going to be a vertical asymptote. So I can go ahead and write that down here. Vertical asymptote is going to be 0. Okay. Um, so let's plot these points. So I've got -2 and a -1/2. Whoops, that should be -1/2, excuse me. -2, -1/2, -1 and -1, -1/2 and -2. So that looks like it is getting really close to that asymptote, but it's not going to cross it, okay? But it looks like it's doing the same thing this way, which it is. We're going to have a vertical asymptote in this one as well. And the vertical asymptote is y equals 0. Let's look on the other side. So on the other side, I'm going to put in 1/2 and I get 2 out, right? Then we have 1, 1, and 2.5. So it's going to look very similar. Oops, it's going to get really close to the vertical and really close to the horizontal. Doesn't cross it. Okay, so that is what our typical 1 over x, our reciprocal function, is going to look like. Let's talk a little bit about the domain and range of it now that we've looked at it. So the domain is everything that x can be. So x can be everything except this thing here that makes it undefined. So it can be everything except for 0. And the way you write that in a fancy way, -infinity to 0, and then 0 to infinity. And you can put a U there. Some people put semicolons there to join them. Okay. Now my range is everything that the y can be. Well, the y can be everything except 0, because notice I've got that horizontal, that green horizontal asymptote. So it's really going to look the same, -infinity to 0, but we are talking about our y's, 0 to infinity. Intervals of increase, is it ever going up from left to right? Does it ever go up? Nope. So we're going to have none. Intervals of decrease, it's always going to be decreasing, but notice we have to watch out for that where the asymptote is 0, where the vertical asymptote is 0. So it's going to decrease from -infinity up to 0, and it's going to decrease from 0 to infinity. Intervals where it's constant, it's always going down, so we're not going to have any of those. Okay. So that is the first of two of our parent functions. Okay, the second one is called the reciprocal square function. So that's going to look like 1 over x squared. So let's do the same thing that we did before. Let's put in some numbers. So with this first one, we're going to put that negative 2 on the bottom. So that's 1 over negative 2 squared. That's just going to be a fourth. Then we'll have 1 over negative 1 squared. That's just going to be 1. Then we have our 1 over negative 1/2 squared. That's going to be the same as 1 over 1/4, which winds up being a 4 because 1 divided by 1/4 is 1 times 4 over 1. So that's just going to give me 4. What if we put a 0 in there? Let's see what happens when we put a 0 in the bottom. See, we have a problem, right? So it's going to be undefined. So we know that we're going to have that same asymptote that we had before. So we're going to have this vertical asymptote of x equals 0. Let's go to the other side. So when we're going to plug in 1/2, well, it's the same thing as this one when we plugged in our negative 1/2. We'll just change it to plus. So instead of it being negative 1/2 squared, it's 1/2 squared, but I wind up getting the exact same number, 4. Same thing if I made that a plus right here, made it a plus 1, I'm going to have a 1. If I made this a plus 2 right there, then I would get 1/4. So these are going to be the same. Let's see what happens. Let's just plot those points, okay? So we're going to have negative 2 and a fourth, negative 1 and 1, negative 1/2 and 4. 1, 2, 3, 4. It goes up pretty quick. Then we do the same thing on the other side. Oh, it's undefined at 0, and then 1/2, it's up at 4, 1, 1, and 2 and a fourth. We are also going to have a horizontal asymptote, and that horizontal asymptote is y equals 0. So let's draw our graph. It's going to get really close to the vertical and then really close to the horizontal. Same thing over here, really close to the vertical, really close to the horizontal. Oh, that was really bad, sorry. I'm going to try that again. Trying to make it nice and smooth, but anyway. All right, so I like to call this the rocket. So anytime you have a reciprocal square function, it looks like a rocket because it looks like you could have your rocket, taken off right now. Anyway, that's supposed to be a rocket, by the way. Not sure what it looks like, but anyway, it's supposed to be a rocket. Okay, let's talk about the domain and range. So the domain are your x's, and the x's can be anything but that 0, right? So it's going to be negative infinity to 0, and then 0 to infinity. That's the way we say everything except 0. The range, notice I don't need any of this graph paper down here. I could just get rid of it. So my range is going to be from 0 to infinity. Intervals of increase. Well, it's increasing on this side, right? It's going up on that side. So it's going to be from negative infinity to 0. On the other side, though, look what's happening. It's going down. It's decreasing as you read left to right. So it's going to be, the intervals of decrease are going to be from 0 to infinity. It's never constant. Okay, so there are my two main parent functions. Let's go ahead and keep going, and we're going to use these parent functions to graph some other things. So we're going to just change a little bit of what you've been given. So this one, negative 3 over x. Which one do you think it's going to look more like? Do you think it's going to look like the reciprocal or the squared function? If you look at the bottom of example number 1, it doesn't have a squared. So it's going to look more like our reciprocal function. Okay, so it's going to be the reciprocal function. I'll write that down, reciprocal. And it's negative. Do you remember when it was negative, what happened to it? Remember the x squared, if we made it negative, instead of going up, it would go down. So we sort of flip it over the x-axis. So it's going to reflect over the x-axis. That's what that negative does. And then do you remember what the 3 does? It sort of stretches it. Stretch vertically by 3, by a factor of 3. All right. So let's just plug in some points, but it helps to know a little bit first. Notice that I've got a 0, I've got an X on the bottom, so that means I'm going to have my vertical asymptote at 0. So I want to, I'm going to plug points in on both sides of that. So I'm going to plug in, let's plug in maybe -3 and -1 and 0, and that'll give us the left-hand side, and then maybe on the other side 1 and 3. It's up to you. I didn't want to deal with a lot of fractions, so that's why I put the 3 in there. Because notice if I put the -3 in, so I'm going to plug it in it right here, I get -3 over -3. Well, that's just going to be 1. If I put -1 in there, that's just going to turn that into a 3. But notice when I put my 0 in, we got a problem, right? So that's undefined. Now I'll put my -3 over 1, and that's just going to give me -3. -3 over 3, that's just going to give me -1. Let's graph those, okay? -1, -3, 1, -1, 3. Okay, now if you remember, this also had a horizontal asymptote. Okay, so it's really going to look like this, really. It's going to go up like that on that side. Now let's look on this side, on the other side. 1, -3, 1, 2, 3, and 3, -1. So it's going to look like this. And that's what we said it would look like, right? It's a reciprocal function. We're going to flip it over the x-axis. So basically this part went up here. Ooh, I didn't mean to do that. Oops. And this part right here, oops, sorry. This part right there flipped and went to the down, okay? Okay, the domain is everything but 0. Remember how we write that in a fancy way? That's our fancy way of writing it. The range, again, is everything but 0. So I'm going to go -infinity to 0 and 0 to infinity, because the y can be anything but 0. Vertical asymptote, that's the green one, and we said that's x equals 0. Horizontal is y equals 0. All right, now let's look at this one. Again, look at the bottom. Does it have a square in it? No, it doesn't. So it's going to still be that reciprocal function. Still going to be reciprocal. Okay, but this time, notice what I have on the outside. I'm going to move it down 1, just like if I had x squared minus 1, right? I would move it down. Now this, on the inside here, the -2, notice that's a -2 on the inside of my function. That would sort of be like what you would do here. And if we did that, we would move it right 2. Okay, so we're going to do the same thing here. It's going to move right 2. So that just means that if I go down 1, that means that my horizontal asymptote is actually going to be y equals -1. And then my vertical asymptote, that's when we say we're going to move it right 2, that means my vertical asymptote is going to move over here. So it's going to be x equals 2. So that helps me when I'm going to plot some points, because I'm going to plot some points that are close to where the horizontal and vertical asymptotes cross. So I'm going to put in maybe a 0 and maybe, let me do it in blue again, 0, 1, 2, 3, 4. That's all. Those are right around where those cross. So if I put a 0 in here, I'm going to wind up with a -2, right? So I'll have 2 over -2 minus 1. So that's going to give me -1 minus 1. It's -2. If I put a 1 in there, I get 1 minus 2 on the bottom. So that's going to be a negative 1. So that'll give me like a negative 3. If I put a 2 in there, unfortunately, I get something on the bottom that I can't have, right? So that's undefined. And let's put our 3 in there. 3 minus 2 on the bottom gives me 1 minus 1. So 2 minus 1 just gives me 1. And the last one, 2 divided by 4 minus 2 is 2. So 1 minus 1, that should give me 0. That's just from plugging in. So let's go plot those points. 0, negative 2 would be right there. 1, negative 3 would be right here. So it looks like it's coming down like this. And now we can't do this undefined part, right? So 3, 1, 3, 1, and 4, 0. So it's coming like that, which that's what we said it was going to look like. It looked like the reciprocal that we moved down 1 and to the right 2. That's exactly what it looks like. Now my domain, notice my domain is everything. Let's see, it's going to be everything from negative infinity to 2, all right? And then on the other side, 2 to infinity. 2 to infinity. And then my range, we're going to be looking at the y. So it's going to be negative infinity up to, what, negative 1? And then negative 1 to infinity. And you can put u's in there, or you can put little parentheses. Let's take a break, and I will do 2 more examples, and we will be finished with this section.